All right. Hello, everybody. My name is Dennis Chef, and I'm SEA consultant at MIDAS IT. And today, webinar topic is RC, Reinforcement Concrete and Steel Design, as per Eurocode for Swedish National Annex. Initially, this webinar was organized for Swedish existing users and new users, but I can see that also engineers from around the Europe and around the world joined this webinar. Even we focus today mainly on Swedish National Annex and Eurocodes. The design procedure for other codes is almost similar, so it will be also very helpful for you. Before start the webinar, I want to provide just several guidelines for a better experience during the webinar. So you can minimize GoToWebinar menu in the right side in order to see the whole screen and to see all functionalities of the program later. I hope you are hearing me well, but you can control audio and sound here. And of course, if you have any questions during the webinar, you can just write it down on the right side, and later after the webinar, we will provide you answers by email that you entered for registration for this webinar. So feel free to write any question during the session at any time. Some of you are already using Gen for some time, but some of you are new for this software. So let me just briefly introduce the main helpful features that we have at MIDAS Gen. Of course, we need to mention about the intuitive user interface. In the software, we have works tree. So basically, you can check all procedures that you've done in the program in the works tree here. So geometry, properties, materials, boundary conditions, loading that you add to the program can be checked and modified easily in the works tree. And you can also interact with Tekla and Revit structures and start. We have also very helpful features for 3D column shortening if you are dealing with high-rise buildings. And if you have project with different construction stages, construction stage analysis is also available. And building model generation wizard is also a very helpful feature if you need to model high-rise building, but also it can be available for low-rise building for repeatable parts as well. Today during this webinar, I will not focus on basic modeling features or analysis features of the software. I will cover design features for RC and steel. So here you can see the general idea of what kind of design features we provide in MIDAS Gen. For reinforced concrete design, you can see Eurocode 2 and 8. And for steel design, Eurocode 3. As RC design, steel reinforced concrete design is also available in MIDAS Gen. Footing design, slab wall design, and capacity design is also available in our program. And later during the demonstration, I will show how we can do this. Again, this is interface of the program, workstream I just mentioned before. And in the top of the program, you can just step by step proceed the whole design process and modeling process in your project. So you start with the structure first, and you can create nodes and elements here, properties for section and material properties, boundary conditions, load, proceed analysis here, and later if needed you can do design as well. And of course, we are all human beings, and during the modeling and design process and analysis process, we can have some mistakes. So this message window in the bottom of the software is very useful for you. So for example, if you try to proceed analysis and at some point it just stuck, so program will write down you what is the reason for the error. So you can check it here. And also table formats that also available with Excel. You just can copy and paste all information from Excel here for working in Gen. Revit structure and Tekla structures are popular these days in Europe. It's kind of trend. And of course, in MIDAS Gen, we provide link between these two softwares. So you can have your model in Revit. Sorry. And you can import it to Gen proceed analysis and design, and if you need to update your model in Revit, you can just work in both directions, from Revit to Gen and from Gen back to Revit. We have this Revit interface feature. So it was just several words about software, what we have. You can check more details on our website, and later we can provide customized basic trainings for you, but today we'll focus more on design functions in MIDAS Gen. And mainly we provide design for steel and concrete, and based on specified design code you can verify whether the section is safe in terms of ultimate limit state and serviceability limit state. So it's available here. And also optimal section design is provided in MIDAS Gen. So basically engineer can optimize the section size. You can find the smallest section size in the program. And in case of RC design, Gen provides frame design for beam, column, wall design, and mat foundation. And also it's available for 1D and 2D elements. So they can be verified based on the design codes, and you can check whether the section is safe or not. Capacity design is also available in MIDAS Gen. I think it's not a major issue for our users in Sweden, but just for information, capacity design as per Eurocode 8 in Gen is available for non-seismic zone and seismic zone. So if you have projects for this topic, you can be sure that we have this feature. And regarding footing design, it's available in additional models. It's called Design Plus. Later in the end of my webinar, I will show you how to use this additional tool called Design Plus. So this table shows available design codes that we provide, and we provide standards for RC design, American standard, European, British, Indian, Canadian, and national European standards like Italian or Swedish, and Chinese, Japanese, Taiwanese, Korean. And for SRC design, steel reinforced concrete design, we also provide these codes. And for footing design, you can check here, slab design is also available. And straight footing, isolated footing, composite beams, column, batch wall, ball joint, and base plane is also available in Design Plus. And we are continuously keeping development additional models in Design Plus for Eurocodes. So data can be easily exchanged between Gen and Design Plus, and basically we just perform global analysis in Gen first, and later we bring member force from Gen to Design Plus for those unit members that we want to design. And we are going to check it later during my demonstration at the end of the webinar. And here you can check all available database for material, section, and loading. So we provide Eurocode 2, Eurocode 3 for steel materials. And what is important, sorry, we also provide Swedish national Annex for concrete and for steel. So let's start first with the first part of the webinar. It's RC frame and wall design. So before I start to work on the model, I will just explain about general parameters that you need to set up before design and why we have these general parameters. So as was just shown before in the presentation slide, we have structure, properties, boundary, load, analysis, results, features here. And in case if you need to proceed design, you just go here. For RC design, steel design, and SRC design, cold form steel design, just go to this menu. And for mesh design, you can check it out here. Before proceed design in MIDAS Gen, you need to define load combination. And load combination available for concrete design, steel here. And we have this feature auto generation. So basically program will automatically generate all load combination according to Eurocode 2 and Swedish National Annex if you check here. Also you can check the database for other codes available. And when you define this, you can at any time change any load combinations that was entered here. by yourself. And also, if needed, you can check and modify a factor for test purpose or, for example, for overseas project on the right side. And for some repeatable data that you have in your Excel file, you can just copy and paste it from Excel file and enter it here for load combination data for your project. Personally, I think it's a very good feature of auto-generation because it saves your time. And also you can see here that you can modify whether it's ULS or SLS, and both features are provided in MIDAS Jam. So when you use auto-generation for load combination in the design, you can check that sourceability load combination type will be also selected automatically. So all of these loads that was automatically generated in load combinations, they will be automatically separated for quasi-permanent, frequent, and characteristics. In case if you didn't use auto-generation function, you can just do it manually by yourself, just selecting the load that you need and just putting in the quasi-permanent or frequent and characteristics. And also before performing the design, there are several functions that we need to check. For example, like effective lens factor or moment magnification for design. And in order to correctly design the member in your project, you need to understand why those functions are there. So let's go back to presentation slide. So first is definition of frame. You can define frame whether sway or non-sway for moment magnification. And also effective lens factors can be after calculated in a gen. If you would like to use your own effective lens factor, you can enter it in the program as well. And this will be used for checking the slenderness ratio later during the design procedure. So let's check it in the program. So definition of frame, you can choose whether sway, non-sway, and you can check how to calculate effective lens factor here. Another important design parameter is member assignment. And why it's important? Because, for example, we have this situation, this is a top view of the member, and because of these submembers here, in order to consider connectivity between this main girder beam and these two beams, we need to divide this main beam in gen. So it will be nodes here dividing the beam on the three different parts. But if you want to design this main girder, you do not want to design it as three different members, of course. In this case, you will use member assignment feature. Again, let's go back to the program, and member assignment is here. So in this case, you'll just this is not the case. I will just show you for your information. So for example, if you have this main girder divided by two parts, you can do it whether automatically. So program will automatically detect nodes which are dividing one member without vertical element. And those can be selected by the program automatically, or you can just do it manually by selecting these elements and adding it. So it will be assigned as a one element. Another design parameter that you need to enter before proceeding design is branch lens. So again, if I just start from the beginning, so all of design parameters that you need to set up before proceeding RC design is here, and I'm just mentioning one by one the most important. So branch lens. Branch lens can be defined here. So in branch lens can be detected by the program also, and you can modify it if it's required. So If you don't want to consider, for example, lateral unbranched length, you can just check it here, and LB will not considered. You can enter by yourself torsional unbranched length, and LY and LZ should be also defined here. And if you consider lateral unbranched length, you can specify it's in this menu as I just mentioned before. And in case if you don't want to consider, so the same value for this unbranched length, LZ, will be used for lateral unbranched length. Also, very useful features that I want to mention for you is maybe already existing users maybe know about this feature, but just to mention for new users, if you go to boundary, you can find beam end offset and panel zone effects, and I just want to explain a little bit more about this feature, why it's important. For example, we have this part, this overlap part in the model, and you don't want to consider the member force from the end of the section, but in this column face. So in this case, you can use beam end offset, and or another function is panel zone effect. So what is the difference with this one? In panel zone effect, if you select this, program can detect the section size, and then the member force in the column face can be used. But in case of using beam end offset, you can just directly enter the size dimension for each direction here, and it will be considered in the program. So here in the presentation slides is explaining more the theoretical background, how it's calculated and how this feature is used. So later after this webinar, I will send you all presentation slides in PDF file by email that you entered when you registered for this webinar, and you will be able to check it by yourself in more details. And if you have questions about these features, you can ask us anytime by email. So for RC design, we have this available section. If you're talking about beam, it's rectangle and T-shape is available. For column, solid box or solid round or hollow circular section is available. In case of wall, we can design straight wall only now. And if you need to consider, for example, combined wall or core wall that doesn't have straight shape, we can use design plus option for this. And later I will show you how to do design procedure for combined walls using design to design plus. As just was mentioned before in the program, you can auto-generate load combinations, and it was already shown in the software. So later you can check in more details by yourself, and design code is available and Swedish National Annex is available. In case if you consider static seismic or response spectrum loads, you can check this consider orthogonal effect for this. And also in MIDAS Gen we provide this 100 to 30 rule that can be also considered by selecting this option. And before performing design, we need to consider serviceability parameters. So let's go back to the software. So you can enter serviceability parameters here, and it can be done for stress here, and for crack and deflection checking. So in order to calculate allowable stress, deflection and crack widths, these parameters can be entered here, and they will be used for calculating of allowable values later when you proceed design. And also I need to mention about short and long-term load cases. because it's required when calculate allowable stress and long-term allowable stress and short-term allowable stress should be classified as per Eurocode, right? So based on this classification, program will calculate the allowable stress for short and long terms. So you can define it here by selecting and drag it whether to be long-term or short-term, and later it will be considered during the design process. So I just define it like this. And partial safety factors also can be considered here. So you can specify the desired chord. It was already defined as a Eurocode and Swedish national annex. And you can define also these parameters for concrete and steel according to Swedish national annex. But in case if you want to do, for example, some test purpose or, for example, overseas projects, then these factors should be different. You can just enter it by yourself, and it's available in the program. And also before proceeding design, you can go to analysis, P delta, and in this case, you can consider P delta analysis and enter all of number of iteration, for example, that will be used and convergence tolerance here. And as was mentioned before, this partial factor is automatically entered based on Swedish national annex. And if you need to enter any other values for overseas projects, it can be easily done in the same menu. And also let's check design criteria for rebar. So this design criteria for main rebar, for column design, breast design, for shear wall design, this can be entered and checked here. This is important for member design, member checking. We can select the desired reinforcement and which rebar will be used for automatic design. So here you can see different rebar codes that we have. So now you can see that only this code is available. If you want to choose, for example, here it's not available. Why? In this case, you can go to Tools, Preferences. It's a very important menu for our existing clients. So you can check and modify everything here, and you can change rebar code here, for example, to a different one, and it will be changed in the menu for design criteria for rebars. So here it's changed to this criteria, right? So you can enter it by yourself. All right, so if you already use Gen for some time, you can see that we have concrete code design and concrete code check. And you can have a question, what is the difference between these two features? Why we have code design and code check? So let me just go back to presentation slide to explain what is the difference. So design and checking. In case of design, based on the data for main rebar and stirrups that's engineer entered, program will show how much reinforcement is required and spacing for them. So program will recommend required reinforcement. But in case of checking, it's mainly for engineering experience. So after proceeding analysis and based on constructability and your own experience, you can enter reinforcement by yourself first, and you just want to verify if input safe or not as per Eurocode. So you will be able to check report which part is safe and which part is not with ratio. You'll be able to check calculated ratio, and if required you can modify reinforcement and check it again. So again, the big difference between these two features, concrete code design and concrete code check. in this feature, concrete code design, program recommend requires reinforcement, but in concrete code check, first of all, you need to enter rebar first by yourself, and later verify the section if needed. Okay, in this model we have different elements. We have beams and walls and also columns. So first of all, let's proceed beam design. So I just finished a part about mentioning about general design parameters, and now we are going for design. So let's go to concrete code design, beam design. And program will proceed design for beams. And later you will be able to check graphic report and detail report for beams. It's also available to select by member or by property when you check results in the design report. And graphical report will be just one-page summary for positive and negative moment and shear force results, and you can verify it there. And detail report, it's all details about calculation procedure, so you will be able to check it there. So now we have this beam design results here. So as was mentioned, we can sort by member or by property. So what is a property? When we define material or section in MIDAS Gen, all of this section of materials have ID 1, 2, 3, 4, 1, 2, 3, 4. Basically, just where you enter it in the program. If you enter this material first, the ID will be first. And same for the section. So here you can select by property. So property 10 and 11. Basically, just section 10 and 11 that we defined before. So let's check what kind of properties it have. It just solid rectangular section here. H and B can be checked here. And also we can check by member. So member, you can see the member numbers here. And in MIDAS Gen, we have very useful feature because in Gen, we are working with nodes. You can select nodes here and elements here. So for example, it's showing element 1586, 1586, enter, and you can find this beam here. So basically this is for each member, you can check it. And also if you want to connect and link the table of the design report with your model, you can click here, connect model view, and whenever you check any member on the model, you will be able to see them in the model as well. So you'll be sure that you're checking it for the proper element and beam. So let's check what kind of results we have. Everything seems to be okay here, but if I'm checking by property, I can see red color. So red color, the sign that something is wrong with this section and we need to redesign it. So for example, let's select this member, and we have graphic report and detail report as was mentioned. Let's go first for the graphic report. In the graphic report, you can see the section, first of all, design information, design code that we choose, material data, section property that was defined for this section. And here you can see the reinforcement that program proposed for these stirrups. Bending moment capacity for positive and negative moments is calculated here. So you can check the ratio for, you can check ratio here. It's okay, it's less than 1. And shear capacity also can be checked here. So this is a graphic report. And in case of detail report, you can check more information regarding this element. So first of all, you can check section size and whatever what was entered in the program before, material properties that was used. And also you are able to check member force from which load combination was found, and reinforcement that's program recommended for you, and other design parameters like partial factors can be checked in this detail report, minimum and maximum reinforcement requirement, and also shear calculation we can see how resistance was calculated in the detail report. And you can see also that software tells us that in this case for this member, shear reinforcement is not required. So all of these details will be provided in detail report. And also you can update rebar for this beam by clicking on the update rebar, and all updated rebar will be updated in the works tree. You can check it here. And if needed, you can change the number of rebar, depends on the design results. I mean, number of reinforcement for leftmost part, rightmost part in the center, and size of the rebar also can be changed here for the most left part, most right part, and center. There is some question from client. I can see that one client is asking that is timber design is supported in Gen or Design Plus? Unfortunately, timber design is not supported in Gen now, and in Design Plus it's also not available yet. Okay, let me go to column design. So again, for column design, you will go to Concrete Code column design. And in order to save the time, let me just select some columns maybe from this part. So for new users, I want to mention that we have different options for selection. So this selection single, selection by window, and we can also select by polygon. So all of these selection features is available. In order to unselect, you need to click this unselect feature. So it's a different selected features. Maybe that is a little bit different with what we usually use in AutoCAD, right? So let's go for column design here. And for column design, we will have the same results that we have before for beam. We can check graphic report and detail report as well, but it will be just one difference I will show you, because for column we also need to consider actual and moment interaction. So it will be also available in this design report. So let's just check for this member, graphic report first. So again, you can see design conditions for this column that we entered before, applied loads, actual forces and moments capacity check will be proceed here. You can check moment ratio and actual load ratio here. It's okay for this column. And the difference is that we have this PM interaction diagram that is considered for columns. And shear force capacity check can be displayed in this graphic report, and shear force capacity check as well for end, middle. You can check all of these details in the graphic report. And the same will be for detail report. I will not go to more detail there. And draw PM curve. This PM interaction diagram can be also checked in 3D format in the program. Wall design. So if you go to RC design and you can check wall design here. Actually in MIDAS Gen we have a specific element that's called wall, and if you have a model like I am showing now with the wall elements here, you can check that have beam plate and wall elements. So wall elements are here. In this case you can use this wall design feature. But there are two ways to model walls in Jan. So later I will also show you design feature for walls when it's modeled as a plate element. Because if you go to Node and Elements, create elements, you can check that we have wall element here. It's a very unique finite element, finite methods element that we have in Jan. And also we have plate element. So for high-rise buildings that's taller than 10 floors, we recommend to use this wall element. But in case if you have low-rise building, plate element will be can be used as well. So in this case, in this model we have wall element, so we can proceed wall design for this. And also in case of wall, you can check PM diagram as well as for columns, and PM diagram will be shown for both direction, for a major and minor axis. And again, you will be able to obtain graphic and detailed report, and formulas that were used in the program can be checked also in those reports in more details. So you can see this all detailed report, and you can see that it's not safe, so we need to proceed design again for these walls. And let's maybe check this and see what kind of information we have. So for this wall, we again have able to check applied loads, design condition, and the same as for column, we can check actual forces and moments here. And if actual ratio and moment ratio is okay, we can check it here. And PM interaction diagram is also available. If you are working with this project, I'm using also features activate and deactivate. As was just shown before, for example, I want to show only walls and I want to work only with walls. So in this case, I can go here and activate, or just press F2 to activate only walls. It also can be very useful for some complex projects that you can make, that you can have in your company. Graphical format for design results is also available. You can check it here, concrete design, and you can choose load combination for which we want to see and what kind of output you want to check, and the program will show in the graphical format which member exceed the ratio 1, and it means that it's not safe and you need to proceed design for this element again. And also you can check reinforcement in this graphical format as well. So let me show you. I will just activate one floor to make it more visible. So you can check also here the reinforcement details for major rebar and shear reinforcement, and all of this data also can be checked in graphical report and detail report, but just for maybe visual purpose, when you want to communicate with the client, you can also have it in a more visible way. It's going to be displayed here. Another very useful feature is section for design. It's here. Why this feature is important? For example, when I proceed RC design for beam elements, you saw that some elements was not satisfied. It was in a red color. So for these elements, we need to proceed design again. And in order to make this procedure less energy consuming, we have this section for design. So for example, I can see that for this property R4050, it's not satisfying now. So what I will do, let's check what is the section. So this section is not satisfied, and I can see dimension of this section here. So if you don't use section for design feature, you can just modify section height, for example, here from 0.5 meters to 0.7 meters, and all analysis results will be deleted. You will need to proceed analysis again, and after that you will do design. But if you have many beams like this, it can be time consuming. So just for checking purpose, you can use section for design feature. You can find this R4050 section here. You can click modify, and you can define this section maybe for 0.7. Click OK, and proceed design again. So this feature is very helpful in order to save your time. So you don't need to perform analysis again and again to check this section. Oh, it's not satisfied yet. So you can change this section again. Maybe change section dimension more and modify it. And later you can see it's here in the tree menu that properties for this section is the same here. So in order to have the final results, not for checking, but for final design, you will need to change also dimension of the section here. Let me open another model to show you functionalities for slab and wall design. If I just go back to presentation, in the presentation slide later you will be able to check all formulas and calculation procedure that we use for calculating bending, axial force, and bending with and slenderness ratio can be checked here. For ultimate limit state design, all formulas can be checked by yourself here, and it's very familiar with you because we took all formulas from Eurocode, and for beam design here, for column design, and for wall design. And it just shown as it was shown before in the program, we can check all of these design results for beam and column and wall here, and you can modify the rebar input. It was also shown during the demonstration, and section for design is also available. It was also shown before. Let's go now to another part of this webinar is mesh slab and wall design. So for mesh slab and wall design, we have the same procedure. So in order to proceed let me just activate this part in order to save time. So in this model I have beam and plate elements. So the difference with previous model, this wall was not modeled as a wall element. It was modeled as a plate element, and also slab was modeled as using plate elements. So in this case, we cannot use this feature that was shown before for a wall design if we want to design this wall. In this case, we need to go to mesh design, and we have another feature, wall design here. So again, to be clear for your projects, if you are working with the wall elements, you need to do it here. And in case if you are working with plates for a wall element for walls, you can do wall design here. Again, before proceeding slab and wall design, you need to enter load combinations for concrete or for steel. I already did it for concrete according to Eurocode and Swedish national annexes. So it's defined. And for design, just go here and let's check also serviceability load combination type. It was also automatically assigned by the program when we auto-generate load combination. So you can check it here. And if you need to modify anything, you can just modify easily by yourself by drag and drop from one side to another side. So we also have this feature. It's meshed slab wall load combinations. Why we have this feature? This function is very useful in case if some engineers do not want to consider all load combinations that we define. So you can just unselect one load combination for this project, because it can be for some, for example, international projects when you don't want to consider vertical load combination for slab design. So you can unselect it here for slab and for wall. Slab wall rebars for checking. You can also modify all rebars here and check all details. For top, bottom, it can be defined here. And you can check which reinforcement will be used for design. And again, you can select the rebar here, what kind of code is used. And you can see this basic rebar for slab and mat. So what is that? This feature is useful for considering practical design. For example, you want to consider, just for first consideration of engineer, you want to consider the same reinforcement on the slab with the same spacing. So in this case, you will check this basic rebar for slab and mat, and the program will proceed design for slab with the same reinforcement and same spacing. And later, after proceeding design, you can modify the reinforcement for column heads and other parts for some critical parts that should be defined. And the basic rebar, if you check this, it will be entered for whole entire slab. Let's check what kind of serviceability parameters we can check in MIDAS Gen. So again, stress is available and also crack control is available and deflection. So let me just select this part of the model in order to save time during the design procedure. So we're just working with this part. And let's start with slab flexural checking, slab flexural design results. So in this case, you again can check what kind of load combination you want to work for. You can check all load combination or just desired load combination here. And always in Gen you can check legend and type of display with values or not. And for flexural design you can check required rebar and also required reinforcement and also position of neutral axis that can be checked, and wood armor moment is also available in this checking. So let's check for wood armor moment. And if you are not familiar with wood armor term, you must be familiar with design force, which converting torsion of the slab into two different direction of reinforcement. So considering torsion, we calculate required reinforcement for X and Y direction. And also in the program, we can define the reinforcement direction. So here we have results for wood armor moment. You can also check the values here in more details for each part of the slab. This can be checked. And I just mentioned about reinforcement direction, how to change it. So you need to go to works tray again and to domain and properties. And in the properties you can see direction 1 and direction 2. So you can change angle from global X and XY and angle from direction 1. So you can enter desired direction by yourself here. If you're going back to flexural checking, you can also define rebar, required rebar. It's going to be checked by the program for all load combinations. And I want to mention that required reinforcement in GEN is calculated based on elements. And you remember that I consider basic rebar when I select the rebar for this design procedure. And basic rebar is applied to entire slab. And for additional reinforcement, you can check it in the legend later when you can obtain the results. Some of you asking about punching shear. Yes, it's available in MIDAS Gen, and after proceeding this slab checking, I will show you also punching shear, how we can do it in MIDAS Gen. So here you can check also results for required reinforcement rebar for each part of the slab. So let's me move to punching shear. So in case of punching shear, you need to move to slab shear checking. And you can see two different options in slab shear checking. The first one is force and stress. So what is the difference between these two options? In case of force, the calculation will be done based on Eurocode formula, so it's very familiar with you. But in case of stress, because GEN is a finite element method software, program can divide each part of the slab and determine shear stress at each point. So this is available. And in this case now I'm checking punching shear based on the stress option. So let's see the results. And for shear checking, not only critical parameter, but also calculation for column face will be proceeded. So you can check design report here for shear checking and all values that was used here, we can see that the ratio is okay. For deflection, we have cracked and uncracked. If we perform cracked analysis, we can also check crack deflection. So crack section analysis control is here. You can check the crack section analysis control here, and number of iterations and load case can be defined. Convergence tolerance also can be defined here. And we need to define both number of iteration and convergence tolerance because it's non-linear analysis and both parameters are required. So we can check uncracked deflection, crack deflection, and long-term deflection considering creep, and we can see all details in the detail report format. And while the program calculates, I will also mention about stress checking in MIDAS Gen. So this concrete stress will be calculated when the program checks it. So the procedure is like this. First, program will assume that it's uncracked section and stress for concrete and steel will be calculated. Later it will be compared with crack stress or steel stress. And if it was the same for bottom and for the top, concrete stress is calculated and compared with crack stress in the program. For long and short term will be considered because we defined it before in general design parameters. So for flexural design, we can obtain the following results, as was just shown before in the program. Rebar spacing and diameter, required rebar area, required rebar ratio, resistance ratio, and wood armor moment. In the detail form and the table form for mesh slab design forces can be checked. Rebar for checking was also mentioned during my demonstration. And here in the presentation slide, I also mentioned some information about calculation procedure for wood armor moment. And as we just checked before in the model, for punching shear checking, we have different options, stress and force. So you can see it here. Stress option was shown in the demonstration for Gen as finite element method software, and for force is calculated using this formula from Eurocode. And if we select stress option, case 1, program will calculate it for each point based on finite element methods results. Punching shear checking is also explained in more details here. And also in the presentation slide you can check more details how the program check stresses, crack and deflection, and crack section analysis. Details can be obtained here. Okay, so here we obtain deflection results for these slabs. You can see all values here in more details. And let's move to wall design for this model. Because we have wall here, let me just activate all model. So in this model we model walls not like as a wall element but as a plate element. So in this case you can use wall design. And again in the wall design you can check required rebar and also required reinforcement area and resistance ratio. And all values for a wall element can be checked here. And you can check results also in a legend format on the right side whenever you check any results in MIDAS Gen. For walls we can obtain rebar spacing and diameter, required rebar area, required rebar ratio and resistance ratio. And also detailed results for walls can be obtained in detail report. And you can check required vertical reinforcement here, as was mentioned before. Let's go to steel code check, because yesterday when I was calling to engineers, I realized that many of you have steel projects. So it will be very useful if I just briefly mention about steel code check in our program. It will take maybe just 15 minutes to finish my webinar. I'm sorry for maybe making too long because I put too much context for this webinar. So for steel design, we have these available cross sections. You can check from the table here for box, angle, channel, T. So we can check this parameters yielding flexural block link that is available in the program. And also in the presentation slide that I will send you right after this webinar, you will be able to check all calculation formulas that's used for steel design in our software. But now let me just show how we do it in the program. And for this one I will open another project for steel. So we have this steel project, and again in order to reduce time, let me just activate maybe this part and show you what kind of results we can have. In order to proceed steel design in MIDAS Gen, you can go to steel design and you can choose a code for steel design. This can be Eurocode 3 and national annex is Swedish national annex in this case. And we have steel check. So let's go to steel code check. When the program finishes the steel code check, you will be able to obtain graphical report and detail report. In a graphical report, we can check slenderness ratio, actual resistance, bending, combined resistance, and shear resistance, right? And in detail report, again, you can check more detailed information about calculation and also details about this project, for example, section parameters, member-related parameters like unbranched length, red length, or effective length for length factor, and section classification, for example, section 1, actual resistance. So all of this can be checked. So let's see what we have. Again, for steel, it's the menu composition is almost the same for RC design. So we can see the graphic report for property and for member here. So and we can connect the model view with what we have. So let's check results for this graphic results. So in the graphic results, we can check slenderness ratio, as was mentioned before, and actual resistance and bending resistance here. And the program will show us that it's okay if it's less than critical value. Combined resistance is also available, and shear resistance can be checked here. And of course, design information that we defined and said before, and member forces and design parameters can be checked as well here. And you can check also detail report. And in detail report, again, we can see section parameters here, section properties that was used for this project, and member-related parameters, unbranched length, and effective length. Section classification will be done by program automatically, and shear buckling resistance. So all of these details can be checked here, and also all ratios can be checked if it satisfy or not. Still optimal design is available in MIDAS Gen, and in case of still optimal design, you can define the section here, and analysis options, number of repetition, I will choose just one just to show you fast how this option is used, and press design analysis here for this selected section. So program will do checking and reanalyzing. Of this section, and later we can check details in the graphical report. So for still optimal design, all of these design results can be checked, and all of this section will be examined for strength verification here. And if we enter 0 here, all dimensions will be searched. So let's go back to check details here. For still optimal design, we'll go here. And it takes some time for still optimal design because member verification is required. So in the message window on the bottom, you can see that verification of these members is in the process. So now it's working. Again, you can check, change the section DB here, and allowable parameter can be checked here. Size of the section can be changed as well. And analysis option, we just keep it as well. And design analysis. Let's go for optimal design now. Select all, design analysis. it will reanalyze and redesign it. So for optimal design, we can choose which ratio to check. The section database and height, width of the section can be also changed. And when the optimal design performed, we'll be able to check how the section will be changed. And program will reperforming design. So now it's reperforming the design. Okay, it's done. And you can check graphical report for modify elements. If you click on the graph report, program will generate it. Here. And in MIDAS Gen, if you have situation like this, when you have many windows, you can go to View and tie it vertically, so you'll be able to see all results that you obtained for still optimal design. So let's see what kind of design results we can see here. So first of all, we can see the weight ratio here for design, and you can see that red color is the original section, and after optimal design it will be shown as a red color. Weight sum graph and average ratio for optimal design can be checked here, and optimal design maximum ratio is here, and weight for each section you can check the section name here, how it's changed during the optimal design. Okay, I almost finished my webinar. I will just mention about external tools for MIDAS Gen that are very useful for your design procedure. So the first tool called MIDAS GSD. It's an internal tool in Gen, and the second tool will be Design Plus. So GSD helps us to design some unique shapes that we don't have in a database in a Gen. And the procedure for design is like this. There are 5 steps. First of all, you will make your unique shape of the section in General Section Designer. And later you will export General Section properties from GSD to MIDAS Gen. And you will perform global analysis in MIDAS Gen. And later you will import member forces back to GSD to check design results. For example, you can see here interaction curve, moment curvature, and stress contour. So there's a step that we need to follow up to check all of these results in GSD. So let's go back to the program to check it by ourselves. Again, I will open another project for GSD. So you can see that in this model I have all rectangular columns on the side, and for this right top column I want to change the section. You can check the different section that we provide in a database here. We have different database and a huge database for angle, channel, I section, T section, box, pipe, solid rectangular, and so on. And we have also combined section, tempered, and composite. It's all available, but let's imagine I have a situation when I need very unique shape for this column. So how I can do in this case? In this case, I can go to Tools, and I can go to MIDAS GSD. And in this separate tool, I can just draw the section that I need for my project. So first of all, let's define the grid. Now it's defined as 0.005 meter. I will define this to 0.001 meter. you need to go to shape, and we provide basic shapes here. So basically you can select different shapes and sections that we already have in the program. Or in case if you have very unique shape, you can go to add general shape and you can just draw it here. So let's do it. For example, I have this shape section. It's just for test purpose. And you can also define the material for the section. Just need to go to material, click three dots, add, and you can select material from the database that you have. For example, concrete 3037. Or if you need your own unique material, you can also choose and define it here. So for concrete, it's like this. Click close. OK. So now we have this section, and what I will do, I will go to Model, Section Property, and I will calculate the section property for the section. So it will be calculated in MIDAS GSD here. I will close, and I need to export this section to different format. It's this format, SEC. So I will save it as a test section 1, save. And I will go back to MIDAS Gen, and now you can see in the tree menu what kind of section I have. I have all of the section here, and the section for column now you can see here, C4. If I double click it, I will be able to see it's in the red color. But I don't want this for this column, right? I need to change it. So I will go to Properties, Section Properties, and I will click on the Add to add a different section. I will go to Value and General Section, and I can import SEC files that I just defined before, test section 1. Open. Yes, this section is correct. All section properties was calculated before. All right. And you need to enter the name of the section. Let's call it test section. Enter. And in the tree menu you can see that this section is here, so we can define it. In order to give this property to this column, we have very good feature called drag and drop. So I will just select this column and drag and drop. So now you can see that the section here is changed. It's not rectangular anymore. It looks more interesting now. Very unique shape. This is the shape that I would like to have. And what I will do now, as was mentioned in my presentation slide, now I need to proceed global analysis. In order to proceed analysis in MIDAS, you can click F5 or click Perform Analysis here. And program will analyze this. So analysis is finished. I will go back to GSD, and I need to link Gen model with what I have now in GSD. So here you can find MIDAS link. I will click on it, and if you have already open Gen, just one model, you can just easily check it. If you have several models open, you will just select the proper model that you have this unique shape. I will click connect, and when this link changed to green, it means that GSD model connected with Gen, so now we can work. I will go back to Gen, and I will select part of the column I want to design. So selection option here, select it, and when I select it in Gen, it will be automatically checked here in GSD. Element number is 405, sorry. So you can check it again here. Yeah, the selected element number can be checked here. It's correct. I will click import, and program will ask me if I want to import old load combination for this element and what kind of for which part I want to work. part I, J, or 1/4 sort force of this part. So I will select just all load combination for test purpose, click OK, and all load combinations that I had in MIDAS Gen will be automatically imported to GSD, General Section Designer tool. So what I will do now, if I need to edit some load combination, I just right click on load combination here and I can define or delete or edit any load combinations that I have. And let's define reinforcement. For defining reinforcement for this section, you need to go to main reinforcement, and there are different ways to define reinforcement by point, line, arch, and perimeter. I will choose perimeter, it's easier in this case. So rebar material we can choose here, and you need to select the section. For selection, you can have this selection window here. Alright, and rotate angle, let's make it 20. Alright, so I have reinforcement, and let's just edit some analysis parameters. So I want to use nonlinear properties in this model. So for this one I will go for nonlinear properties and define some parameters here. So let me check. For this I will use 003, and for this 0.035. Alright. Okay. And later you can also find this design section function. Just click on it. Program will ask you how to save it. I will save it as a section view 111. Save. And program proceed design for this unique section shape. And you can obtain all design. For example, for each load combination, you can check the PM curve diagram here, and all of the results for force and moment, My, Mz will be defined here. Also, you can check moment curvature curve here and stress contour. So maximum, minimum value can be checked. Also, you can see the neutral axis. And again, for each load combination, you can see how the values are changed. So this is general section designer in MIDAS Gen. And the last part of my webinar for today. I'm sorry to take too long time for you. Give me just 5 minutes to finish. So we have Design Plus. It's also a very useful feature. And for RC design, we provide these features. For steel, this one, and for steel reinforcement and concrete, we can do this. So I will not go to many details about this tool. I will just show you how to do design for combined walls. So let's go back to Gen. Open the proper project. So I have this interesting project with different elements, and you can see that I have strip foundation and I have combined walls here. So these are my combined walls. So let's go to Tools again and go to Design Plus and check what kind of functionalities we have for this option. Let's just quickly check the code. It will be for Eurocode. Apply. And rebar, I will use this rebar code. Apply. And also you can check some preferences for design here. So I will just check this share wall, design methods as 2 methods. Alright. And you can see that these features is available for Eurocode too. So column, footing, share wall, and this for steel and SRC. So let's go to share wall, combined wall, and the program will open the template for combined wall. So if I go back to Jan, I can select the wall for which one I want to proceed design. For example, for this wall I want to do design in Design Plus. So again, the same with GSD. You need to link your Jan model with this and select the desired wall in Jan and import it to Design Plus. When it's imported, you will be able to check all calculation results here. For shear capacity, moment capacity, PM curve interaction can be checked here. And also you can obtain reports, detail report, summary report, input list in Excel format as well. For detail report, it can take some time. In order to reduce time, you can use these features in the top. So we have project mode and simple mode. In order to just quickly check, you can go to simple mode, and for report, detail report can be checked here for all desirable results. For shear capacity for this combined wall, you can see that it's red, it's not satisfying, so we need to redesign it. And also drawing in Design Plus is available. So for the selected shear wall, we can obtain the drawing with all information, geometry, and reinforcement inside of the program. And quantity report can be obtained for this as well. So quantity report for a section and combined wall details can be checked here. All right. Original time for finish this webinar was 6 o'clock. I'm sorry for taking your time until 28, but still we have a lot of participants, so I can see that you have a high interest. If you want to check more details about our products and about Jan, you can go to midasuser.com and check all details there. And you'll be able to see training tab there, and you can find a lot of tutorials for Jan. Also, we have YouTube channel for Jan and other products. So if you just go to YouTube and write down MIDAS Jan, you will be able to check all tutorials and webinars that we proceed before. If you have any questions, just feel free to send your question to esupport@midasit.com or call us at any time. And also, I am available for your questions by my personal email. And we have a lot of questions during this webinar, so I will reply you within these days and until tomorrow morning by email. And if you have any additional questions, feel free to ask me anytime. So thank you guys for your time and keep in touch. Beside of this, if you want to have more customized webinar for your company, you can ask us at any time. For modeling and basic trainings on site is available from our site. So have a good day and bye-bye.